Now this part here, we are looking at compound bars. Okay. The other day, I have taught you how to use principle of superposition. Now today we are looking at the compound bars. Okay. So you have bar of varying sections. Okay. So one of the method that we use in solving questions on bar of varying sections that I have shown you, that is by using the principle of superposition. Now, what are these compound bars here? We actually have bars of different sections. That means varying sections, bar of varying sections, or bar of different sections. Just like what I have shown you here, this diagram over here. This we call bar of varying sections. So when you look at the green section, the red and the blue, they are actually of different cross section. So if let's say, for example, you were to solve problems, this type of problems, that means bar of varying sections, or sometimes we call this as series bar. Okay. So one method is applying principle of superposition. Applying principle of superposition, solving the problems. The other method is you have to remember the formulas. Let's say, for example, for series, we call this a series bar. In other words, bar of varying sections, we can call it a series bar. Then we can find out the total deformation of the bar by looking at this formula here. This is the total deformation, that means the total elongation, equals to the deformation of the first section, that means this, let's say, plus the deformation of this section, the section 2, and the deformation of section 3. So once you have found out the deformation of each section, what you need to do is you just add up, okay, all the 3 sections together, the elongation or the deformation of all the 3 sections together, you get the total deformation. That is the first criteria, okay, for series bar. Then the next one is we take the force that is acting in this section, in this part 1, must be equal to the force that is acting at section 2, that is part 2, and also the force that is acting at section 3, part 3. But in this question here, if you have questions like this, only if, let's say, for example, you have the force acting at the outer edges only when there are forces acting at the outer edges. So if you have forces acting at a section, let's say here and over here, then you cannot use this theory here. Okay, so you have to apply the principle of superposition. The principle of superposition. So that is what I have written here. Total deformation, first thing is this. Total deformation of bar is equal to the sum of all the deformations of each individual section. Okay, that is this. Now, determination of forces acting on each section of the bar or the bar itself will have to apply the principle of superposition. So you either apply principle of superposition, okay, if you have forces acting at various sections of the bar. Then if you have only one force, a pair of force acting at the outer edge of the bar, then you can straight away apply this. But then it is not advisable to use this always, okay? So that is for series bar. Then, of course, when you say series, then of course you have parallel bars. And we usually refer to as composite sections, okay, compound bars. Now, composite bar is, for example, you have, for example, when you refer to reinforced concrete. So you all know what is reinforced concrete, right? Look at this diagram here beside this figure or this diagram beside here. Okay, this we call reinforced concrete. So you have reinforced steel rods. Can you see they have steel rods here, which is reinforcing the whole structure, okay, the whole bar here. So for example, when you have steel rods reinforced, okay, with the concrete, we call it as reinforced concrete. We can call this as parallel bars. Parallel bars. Okay, so that is in the form of isometric view, but then this one is a plane figure. So when you look from this direction, that means the side view, you can see the cross section of the bar of the reinforced concrete looks like that if you have 5 reinforced steel rods. Okay, another example is when you have a steel bar, okay, which you have a reinforced or something that is placed inside of the first bar. So example this, when you have a hollow steel bar with a copper rod in or inside of it. Okay, so this can also be considered as a parallel bar. So for parallel bar or for composite bars, then we have to follow these formulas here. Okay, so this one gives you the deformation of the steel rods. Any deformation that occurs on the steel rods has to be equal to the deformation of the concrete. Okay, the deformation of the steel rods has to be equal to the deformation of the concrete. So if, let's say, for example, the steel rod is inside the concrete, the steel rod is inside the concrete. Why I have drawn it out like that is just that to show you that, okay, what it means by reinforce. So you have steel rods, okay, reinforced in the concrete. Okay, so the first thing you have to consider is the deformation of steel rods must be equal to the deformation of the concrete. Whereas when you refer to series bar, the total deformation or the deformation has to be the sum of deformation of each individual section. For parallel bar, the deformation is the same. For series bar, the deformation, you have to add each deformation. That means the deformation of each individual section. But then for parallel, the deformation is the same. For the forces or for the load, if we were to find the total force for a composite bar or for a parallel bar, you have to take the force absorbed by the steel rods plus the force which is absorbed by the concrete. The force that is acting on the steel rod plus the force which is taken up by the concrete column. That will give you the total force or the total load. Okay, but for series bar, you have to apply the principle of superposition. For composite bar, you just add up this, okay, the force acting on the steel rod plus the force acting on the concrete. You just add it up together, you get the total force. Okay, and also the total force also can be changed into this format here. So here you have forces. Okay, now we know that stress, now the earlier formula, the definition of stress is force over area. That is when the stress is the subject. So if I change the force to be the subject, then it will be stress times area. Stress times area. Okay, so I hope you all remember what we have done earlier. Okay, what is the definition of stress and why this became this section here, this part here, because okay, stress equals to force over area, and then if you change force to be the subject, then force to be stress times area. So this gives you the total force that is acting on the composite bar. Okay, either you can use this or this. Okay, or it depends on the questions, what the questions wanted us to find or what the questions actually has given us. Okay, that's for this section. The next we will be going to the examples.